Good afternoon, everyone. We'll get started in just a few minutes. I want to give everyone a chance to get connected. Okay, great. Looks like we've got a great turnout so far. So we can go ahead and get started. Welcome everyone to this afternoon's webinar on the J3400 standardization updates and discussion. My name is Delaney Dixon with NASEO. I'm working as the Clean Transportation Program Manager. So great to see everyone today. We are joined today by Jacob Matthews, Senior Advisor for Standards and Reliability at the Joint Office of Energy and Transportation, Rodney McGee, Chairman of the SAE J3400 NACS Task Force and Research Engineer at the University of Delaware, and Christian Thiele, Director of Ground Vehicle Standards at SAE, and then Michael Paris, the Manager of Business Development, Product and Sales at SAE. We're also joined by a few other SAE representatives who will be available to answer questions and chime in during the discussion portion. So definitely excited to hear from everyone on the SAE team. And we're excited to hear some of these experts on updates on the standardization and market availability of the J3400 connector, and eager to learn a little bit more about what's to come in the world of EV charging connectors and how this can relate to NEVI and other EV charging programs. So first, I'll hand it over to Jacob Matthews from the Joint Office of Energy and Transportation to discuss some of the work the Joint Office is doing and the national labs are doing to advance reliability and standardization of the J3400 connector. So Jacob, take it away.
Thanks, Delaney. Hopefully my audio is coming in okay. Let me know if you're not hearing me. Again, it's nice to be with you all this afternoon. I started with the Joint Office last year after having completed about 33 years in the automotive sector, and electrification has been my passion for several decades. So I'm really delighted now to focus on the infrastructure side and working to make charging experience more seamless for customers. I will provide a light touch on the activities of the Joint Office broadly, but then I'll get more deeper into the reliability efforts that our team has been engaged in as we bring on J3400 connection system. So let me just advance my slides here. Sorry, this will be a little quirky from here with these different buttons here. Anyways, as you all already know, the Joint Office of Energy and Transportation was created through the bipartisan infrastructure law that facilitated collaboration between DOE and DOT. The Joint Office, at Joint Office, we help align resources and expertise across the two departments and to have a leveraged outcome. That's our goal. And there are about 9 major areas of emphasis that we're focused on, one of them being technical assistance for zero-emission vehicle charging and refueling infrastructure, data sharing, et cetera, et cetera.
And Jacob, sorry, just to interrupt, we are not able to see your slides. Could you please try and presenting?
Oh, see, I knew something was up. All right, let's try that again. Oops. How about now? Does that work?
Yep, looks good. Thank you.
Okay, thanks. Sorry about that. I knew there was something wrong with my controls here. All right. So I was talking about the Joint Office more generally. So let's go to the next slide here. So our mission, let's talk about our mission. It is at the Joint Office is to accelerate electrified transportation system that is affordable, convenient, equitable, reliable, and safe. And our vision is that everyone can ride and drive electric. All right, so go to the next slide here. All right, so again, continuing on with our vision, we have a four-pronged attack for our vision, if you will. First one is to make sure that we're coordinating and leveraging activities with DOE and DOT, as I mentioned earlier. We also serve as the front door for the federal government on expertise and technical assistance as it comes to charging, especially. And we're also quite actively and proactively engaging as a convener for federal agencies, for private sector companies, NGOs, and academia to bring together everybody, to have everybody on the table, to have a conversation about how to improve our charging and how to get these problems solved. So that's one of our prongs or mode of operation. And of course, we're very keenly focused on having a social return on investment for all that we're doing. And just to, as a recap, the programs that our office is supporting, as you can see there, the NEVI program as it enters the third year, there's a lot to celebrate. We're building out their new charging infrastructure stations getting started up across the country. You also know about our CFI discretionary grant program that was funded by Bill, which provides charging support to communities and corridors, looking at also hydrogen, natural gas, and propane refueling infrastructure, et cetera. We've also most recently launched this EV charger reliability and accessibility accelerator program. It's a bit of a mouthful, but essentially awarded about $148 million to 24 recipients to repair and replace broken and non-operational EV charging ports. And that is again to help improve reliability of the overall charging infrastructure. And recognizing that electrification involves more than just passenger vehicles, Joint Office is also supporting medium and heavy duty vehicle electrification through the low or no emission vehicle program for transit, as well as providing funding to state and local government authorities for purchasing zero or low emission transit buses. And finally, our clean school bus program that we're also supporting in terms of deployment of electric school buses. All right, so let me just get into really quickly, and now since we have some really technical folks from SAE online, I won't get into all the details, but just a light touch on J3400. And as you know, we've already provided this guidance that NEVI charging ports can use J3400 NACS as long as there's one CCS connection that's in place, and that was our initial guidance. And on the horizon, as we can see, J3400 TIR that was published in December, TIR being Technical Information Report. That's a precursor to a recommended practice. And so that document is now being worked on by the SAE team, and I'll let the SAE members explain more about it as they get into their presentation. But as you can see that there is significant movement and breakneck speed of getting this NACS connector into a standard. And so we're equally engaged from the Joint Office side to make sure that there's improvement in charging interoperability and reliability. And we'll touch upon that here as we go forward. This next slide just kind of shows a bit of the two devices and just a quick comparison. Obviously you can see that the J3400 is a bit more of a streamlined design and obviously has some ergonomic benefits, and Tesla supercharging network boasts of a higher reliability compared to the CCS counterpart. But of course, there is the flip side of added complexity on the vehicle side to manage both AC and DC on the same pins. And but on the other hand, the customer can certainly enjoy a much simpler connection system. So, and what we have seen, of course, is this is just another snapshot of where we are with. Oops, my computer froze up here. So, looking at what's happening in the industry, I mean, we've basically seen announcements from all these major OEMs that have made commitments to adopting J3400 as a charge port on their vehicles starting in 25. And so really the market is a seismic shift from CCS to a NACS or a J3400 over long term. So clearly we're watching that, and we'll have to stay abreast of making sure that's reliable and safe as we deploy these. Here's a quick timeline, and this is sort of rough, but kind of shows you where we are, with the J3400 TIR that came out in December. The SAE committee and teams are working on at the moment to get that into a recommended practice. I think the timing there is sort of aggressive, but nonetheless, that's what we're wanting to do, a quick turnover, if you will. And I guess to be seen if that actually does transpire by second quarter. But right behind 3400 is the 3400-1, which is a TIR for the adapter that is also under development, and we expect that to be finalized, and then the UL 2251, 52 standards for testing that can then be utilized by NRTLs for certifying these parts. That's already underway, and hopefully that'll get completed here soon as well. And we see that component suppliers will begin providing certified parts to EVSEs and EV OEMs. That the blue bar there is simply the big range there, but you'll have lots of these parts becoming available. OEMs in the orange bar, they have sort of showed, or at least made commitments of providing adapters for their CCS1 vehicles to charge at Tesla supercharging networks. So you see that transition taking place. And of course, NEVI stations with J3400/NACS will start opening up soon. So obviously we see, Tesla charging stations at first, and then of course some of the non-Tesla stations will migrate as well. So, and then of course the last orange bar there is the US automakers or other automakers will start deploying their vehicles as we move along. So that's definitely a seismic shift, as I mentioned earlier, of transitioning from CCS1 to J3400. Next, I just want to get into a quick talk about what we're doing at the Joint Office to helping to improve reliability and interoperability. We're tracking the overarching challenges to build a convenient national charging network. We're focused on cybersecurity and equity, but also focused on reliability, data sharing, interoperability, and utility coordination. I think the utility coordination is essential as we deploy chargers across the U.S. I mean, it's quite evident that the minimum 600 kilowatts of power along certain highway routes is going to be challenging for utilities to deliver, and so it requires a lot of coordination, discussion, planning, etc. So certainly those are the areas we're focused on as well. The next slide, I just want to go over what our team is engaged in, specific activities. So one of the activities we're engaged in or have been engaged in helping to provide guidance to Federal Highway in terms of the minimum standards and questions that come from the industry. We also help with providing feedback that goes into the Q&A that's on the website. We're also helping in a consultation way to provide reliability metrics for the federal highway, and in addition, we're focused with developing some open source deployment, and this is where we're wanting to have an open source architecture where open source software can be made available to any and all companies. So as we develop and implement the standards that have been called out, communication standards, specifically OCPP 2.0 or OCPI or 15118, as companies develop this, an open source architecture will allow for quick adoption, but also as a reference for other established companies to compare, their code with one that works, that's been provided by the Joint Office for anybody to utilize. So clearly, that's an activity that will help improve reliability. In addition, we have a ChargeX consortium that has been stood up, and I'll talk more about that. There are lots of activities happening in there for that. And of course, we have EV chart, way to share data and collect data. So yeah, lots of activities. Again, just in the interest of time, I'm just going to do a quick touch here and just move on. Also, as we get into the minimum standard, just to remind us, charging has to be predictable, reliable experience for consumers. We've got to have at least 4 CCS ports, and the drivers should be able to easily find chargers, and drivers should be able to pay for the charge session, not have to necessarily use multiple apps and multiple accounts, keeping it simple. And chargers should support drivers' needs well into the future. So our network has to be nicely future-proof as well as we develop this. I was talking about earlier about open source, and so we have partnered with Linux Foundation to sort of help develop that. And again, let me just jump ahead. I'm running low on time here. So, here's the charging ecosystem, and you can see anywhere from EV to EVSE to the back end, communication to the hub, and so on and so forth. There's lots of points in between there where data is being transmitted. And so all across this ecosystem, we want to be able to provide open source architecture, reference software that can be deployed. And this will then allow us to have, a better communication, a better transaction, and in the end, a better response for the customer. The 4 areas that we're actually focused on, the equipment industry, these are the 4 areas we're actually developing the code for at first. And then, of course, we'll develop other points, as I showed in that other diagram, as we move forward. So let me get into ChargeX. ChargeX Experience Consortium. This is GAO-funded activities of the labs that is looking at improving charging experience. And so the vision for ChargeX is quite simple. It's to ensure that any driver can charge any vehicle first time and every time. And that's our goal, is to be able to provide that very seamless experience. I mean, we're trying to make the experience for charging equal to or better than the refueling model that we presently have. And so we have to do really well, really better, so that customers can start adopting vehicles, because that's going to be a key metric for them to switch over. So in terms of defining the experience, there are several areas. There are 3 working groups that are engaged right now in this work scope, if you will. There is one working group that is looking to define what charging experience is, and defining KPIs, performance indicators, that will then be able to, we can gauge our progress by, we can communicate this to the customer, how to measure. And then reliability triage, working group 2, finding out what the issues are and trying to develop fixes for that. And then how to scale for reliability in the future and what sort of systems need to be in place. So high level, 3 big working groups. Outcomes are, of course, to develop recommended practice and developing prototype tools that industry can adopt. And on the far right, you can see all the participants we have. This is a pretty big group of 80 some different companies that are engaged in helping to develop this the system for having a good ecosystem on the charging ecosystem. So just deep diving a little bit more into the charging experience then. So here we basically developed these key performance indicators. What are the important aspects of charging for a customer? Obviously finding a charger, accessing the charger and being able to start the charge session and completing the charge session reliably, those are important factors, right? So, a while back at JD Power, analysis showed that most customers had not even seen a charger on their way to commute. So how will they adopt an EV if they came and don't even know a charging system exists? So being able to have that visibility for current EV customers is going to be important. Anyways, so that's one important aspect. So what the labs have done is they've defined these key indicators, and our goal is to be able to then refine and track performance based on these indicators and continue to develop and refine the charging experience. Another area that we're focused on, let's see, oops, go forward here. Okay, payment reliability. This is another pain point for the customer. We've heard lots of scenarios and issues with RFIDs, with credit cards, and not being able to start and pay for a charge session. That's a huge pain point, right? So we need to be able to remove that, and part of that is what the labs have done is developed a best practice document that should be then adopted by the industry, and so then once it's adopted, we can then demonstrate and track improvements in performance to our metric of providing a seamless payment system. Another area we're focused on, and this is probably the one that matters most for today's discussion, which is the adapter reliability and safety. Clearly, when J3400 was first released after being in development for all these years, it never considered an adapter because right off the onset there was challenges with having a adapter in the middle. And so now that we have CCS and we have J3400, and you're going to have vehicles that are legacy vehicles that will show up at J3400 charging stations. How do we maintain reliability of that adapter? And so the hardware task force, that's working group number 2 within ChargeX, they're focused on all adapter reliability and safety. So it's an important item for us to do deep dive and to understand all the failure modes. And so part of what they're doing is doing an FMEA, or failure modes effects analysis, to understand what points in this interface can fail, can create an issue that can then result in a poor customer experience or something even worse. So this is an important task that our lab teams, along with the consortium members, are engaged in right now to help develop and improve reliability for J3400 as we go forward. I mean, we do not need to have any issues with this as we make the transition, because that will simply slow down adoption and just have lots of, can create some bad experiences. And so that's something we're clearly focused on. And of course, there are other issues with the standard itself. For example, seamless retry. One of the areas that we found is that if there's a communication setup issue, then the charge session will not progress. And so the customer has to unplug and then replug their vehicle to start the session all over again. That's a nuisance, an annoyance. And so how can we solve that problem? And so the lab teams have developed some recommended practice and that they have tested, and it's up to the industry to adopt. And again, that will improve the customer experience as well. Another area is minimum error code. So a lot of times charging systems and charging sessions may fail, but the customer doesn't know what the issue is, or even the operator doesn't know what the issues are. And so having a minimum set of error codes that are transparent, that can be easily communicated, broadcasted. So that's what the lab teams have developed. Working group number 3 has come up with this diagnostic error codes, minimum error codes that we're recommending industry to adopt. And that will allow, again, for quicker problem resolution, quicker identification of problems, etc. And then alongside with that is the data sharing, is that this diagnostic data that we now have needs to be shared. It doesn't do anybody good that there's a code that is set, but nobody knows about it. So then how do we share this data across the industry, across the ecosystem, that issues can be quickly resolved? If there's a part that's broken, can be fixed, so that the station comes back online. So again, developing a method for diagnostic data sharing. And then another important aspect of improving reliability is having interoperability. And as this diagram sort of shows on the right, every car, as we said, our goal is that anybody should be able to charge any vehicle first time, every time. Well, that is not exactly the case today. And so in developing these interoperability test cases, we're looking to make sure that every vehicle is able to charge at every charge station, whether it's NACS, whether it's a CCS, and how do we do that? And so that's what the lab teams have been engaged in, and we hope to be able to demonstrate this year in the near future with doing this interoperability testing with vehicles. And then, of course, in trying to accelerate testing, because there are just so many vehicles coming on scene with so many different charge configurations or charger configurations, we're developing this one of a kind tests method that allows us to connect an EV and an EVSE remotely. So through network connectivity, just having devices that can actually emulate and be able to share data, and then be able to recognize what the issues might be and come up with a fix. So that's another aspect of helping to improve reliability. I'm running low on time, so I'll just jump ahead. And so here's just another timing plan or roadmap of all the activities, and you can see that our goal is to help deliver this very quickly. And so it's an all hands on deck approach. Something that we're not necessarily all used to, but that's what we're trying to do here, is to accelerate as quickly as possible, solve these issues, and provide solutions to the industry and for the ecosystem to have improved reliability and in the end, good consumer performance. All right, cybersecurity is another area we're engaged in, but I think in the interest of time, I'll stop and I'll simply say that our goal for cybersecurity is to make sure that as we make the transition from CCS to J3400, and as we're looking into the communication standard, which is not supposed to change, but there may be some iterations of some minor tweaks. But if there are those tweaks, that we are simply ensuring that cybersecurity is first and foremost, and it's maintained and it's tested. So that's our goal with that. And I think I went a bit over again, just to recap our cybersecurity, lots of different work that's going on. And again, this is to make sure that we're not vulnerable in any of the ecosystem points to bring a network down, or to have any compromises that will result in a bad experience for the customer and the ecosystem in large. So anyways, I think I will end here. thank you again for the time, and look forward to your questions. I guess I'll pass it to our colleagues at the SAE.
Great, thank you, Jacob. I'll hand it over to Christian Thiele from SAE to start next.
Excellent. Thank you so much. Are you able to see my screen?
Yep, looks good.
Outstanding. So with that being said, we're SAE, obviously the J3400 right now standard that we're developing is the major topic here today that we will be discussing, and I want to just get into a little bit of what we are currently and who SAE is currently. And SAE, obviously, our mission is to advance mobility, knowledge, and solutions for the benefit of humanity. We're not only engaged or involved in the standards side. We obviously help the community out. We also have STEM programs, professional and pre-professional educational forums and things that we do there. Resources, we have over 100,000 plus engineers and members that are part of the SAE community, of which we have anywhere from 10 to 12,000 engineers, subject matter experts engaged in standard development at any given point in time. And we obviously do that through a consensus-based neutral type forums. We are also obviously part of the educational side is dealing with training and further educating people, especially here in the charging environment and charging ecosystem. And Mike Paris will address that a little bit more here in the next few minutes. So with that being said, the timeline, the process, obviously June last year, the industry, along with government and several other infrastructure providers, strongly urged the industry and urged SAE to develop the J3400 standard. We obviously had already developed the 1772, and we're in the process of updating that at that time, which we still continue to do. But the J3400, the industry said, SAE, you got to help us out here. We obviously initiated the task force then in June 27 of last year. We had a draft TIR completed relatively quickly. Obviously, the product was already somewhat developed and utilized for 8 to 10 years already in the field. So the development process was somewhat completed to a certain degree in a certain aspect, and it allowed us and afforded us then to publish the TIR on December 19th. That was immediately followed up with a whip opened for recommended practice, which we are planning on publishing here towards the end of Q2, soon and shortly thereafter to be followed by a standard, full-blown out standard. We've had great collaboration within the SME community and within industry and government and supply base. Over 100 plus SMEs are attending regularly on a weekly meeting with a task force. Very heavily engaged. Usually it's always a challenge for standards development organizations to convene and get people to join and develop. Not in this case. The industry definitely was pushing their experts towards the development and towards the committee and the task force to develop the standards. Okay. Let's go to the next page. So the J3400, as you can see here, the document, the TIR was published. This document covers the general physical, electrical function of and safety performance requirements of the J3400, which my friend Rodney will be chatting about here in a little more detail. The technical information report was published, and obviously it was a well-developed and through broad-based industry consensus. As mentioned before, we had over 100 people from all walks of every organization and industry to develop the electric vehicle coupler task standard through that task force. So with that being said, I want to introduce Rodney, who is our chair. And Rodney is our chair as it relates to the task force, the J3400 task force. And he is leading the technical charge from our SAE subject matter experts. So Rodney, with that being said, I will leave that up to you. And I think you can see the presentation on the screen.
me unmute here. All right.
Yep.
Yeah, so there's two things here. On the left is kind of what we've already published, and it includes the TIR, I would say, is actually fairly aggressive. It more resembles what we wanted to achieve more with the recommended practice. However, we were able to, cover quite a bit of the aspects of implementing NACS. So one of the main things was getting the actual drawings and CAD files for the coupler system into the document. There is some slight differences between what Tesla originally published, that some of that information has been pulled down, and what we published in the TIR, and that's because we made some improvements, including point of contact constraints that basically make sure that when you plug in the connector, that it engages properly with the system, despite different designs being made by different manufacturers. We also increased some durability requirements based on recommendations from manufacturers. So, UL only requires that you drop a connector eight times as part of the listing. And I think everyone can just immediately say, well, okay, connectors are going to get dropped more than 8 times. So we kind of went beyond for our North American standards for increased durability. We made a lot of improvements with AC power transfer, which is key for mass electrification. I think a lot of studies have shown from OEMs that drivers who have regular access to AC charging where they park have much higher satisfaction and less range anxiety than drivers which always have to DC fast charge. I think also that we want to, for the goals of things like V2G and things like that, we want to have as many cars be able to opportunistically charge so we can use that renewable energy when it's available. The other thing that we've sort of done is tried to lower the cost of AC charging infrastructure. And there's really 2 kinds of ways that we've done that. In the rest of the world, the United States, Canada, Mexico, or sort of an exception to this, have an option for street charging, which allows for more streamlined infrastructure and lower maintenance costs. So you can actually, get more charging stations with the same public dollar. And so we've incorporated some of those technical things that are already sort of proven in a worldwide way. And also my other role at SAE is I kind of handle electrification for sort of medium and heavy duty vehicles, especially for AC charging. So we made sure that we have interoperable connection methods that allow sort of mixed fleets. So you think of, Jacob mentioned school bus fleets, but you think about the motor pools that a lot of people have. They have some big vehicles and they have some small vehicles, and there's some shared infrastructure there. And we want to make sure that we can handle those bigger battery packs, but still also charge the same vehicles. The standard, the TIR set the requirements for basic AC and DC charging. Of course, we had options for AC and DC vehicle to X, meaning, anything from feeding power back into the grid to backup power for your house or site power. In the recommended practice, the main changes we're really looking at is having a reference device for conformance testing for 500 amp DC charging. So a reference device is basically something you can test connectors against to make sure that they perform adequately. So we want to have one of those for NACS. One of the unique things about NACS is that the AC and DC occurs over the same pins, not at the same time, of course. And there are additional requirements probably going to be added in to help guide the OEMs to have a sort of uniform set of requirements. We're going to fully define some functions related to that'll be important for the adapter document to take advantage of. For communication interoperability, this is probably for many people one of the more important things. We're going to define a set of kind of communication classes. Many vehicles that are going to be produced in the next, few years maybe will support, for example, let's say tier 2A, and then vehicles later will be manufactured that support tier 3A. The purpose of this is to sort of have a way to refer to them in the standards so that you can sort of know that particular charging stations or vehicles support, certain levels of communication requirements. This is related very much to, it was sort of mentioned, what the industry wants is essentially that people can go up to a charging station, plug in, and the charging starts automatically without a lot of interactions with the station. That's the kind of promise of, maybe you guys have heard the terminology plug and charge. In order to do that, there are industry efforts ongoing in collaboration with SAE standards, with SAE ITC, to sort of allow a path for North American plug and charge. Currently, there's not an interoperable system that ensures that, and we're trying to put the requirements together to allow for that. And then there's other minor technical changes related to just defining the space on the vehicle that's needed for, connectors to sort of plug in reliably and certain kinds of accessories. So that's kind of a overview of what we're adding in the recommended practice.
Thank you. I appreciate that, Rodney. Rodney, is there any, and let me go to the next slide just for people's edification and understanding, obviously, the global charging systems that are out there. On the Tesla one, the specifics are identified here in this diagram very clearly. And I think, Rodney, we may want to touch base just briefly on the J3400 -1 that's going on there. If you want to touch base on that real quick as it relates to adapters.
Sure. So adapters have been provided by other OEMs for a number of years. However, the switch to NACS kind of creates the case for a more broad standardized approach to kind of adapters. The thought being that the CCS, the sort of type 1 J1772 existing vehicles, as the industry moves to NACS for passenger cars, that adapters will kind of play an important part there. And so essentially what J3400/1 is really to give the specific requirements around adapting in and out of the NACS system under J3400, while the UL 2252 document is really designed to give broad requirements for adapters, maybe even adapters that have nothing to do with NACS. In theory, it could be an adapter from MCS into CHAdeMO. I mean, just in theory, that's the scope of the UL effort. So 3400/1 is really about defining the specific NACS related solutions for adapters, and the UL document is a companion that provides a third-party testing process to certify that. Although adapters will be provided by OEMs before the UL 2250 process even wraps up, because the reality is that adapters have been provided by OEMs for years, but there's a sense that it's important to increase the safety of these devices if they're going to sort of be more condoned across the landscape.
Great. Thank you, Rodney. I appreciate it. And Delaney and team, I think that covers the summary in regards for the 15 minutes or so that we had. And we look forward to any further questions that is posed to the panel. And I think I hand it over now to Mr. Michael Paris in regards to some exciting news on that front from training aspect.
Yes, thank you, Christian. And I will share my screen also here. Just give me a moment. Once I think the person sharing their screen now, if they just stop sharing, then I think we should be good. But as we do that, by way of introduction, my name is Mike Paris. As Christian mentioned, I work within SAE in our sustainability practice, which is really a new and dynamic part of the organization. It was approved by the board of directors about 2 years ago. And our mandate is a simple one: to look across the business units at SAE International and our affiliate companies and really create opportunities and new products, new programs, and new services that are supporting the mobility industries as we all march toward net zero emissions transportation. So in the spirit of our discussion today, I wanted to take you through a few new products and programs that are specifically related to EV infrastructure and charging infrastructure reliability, as well as a few other items. So you should be seeing my screen now. If someone could just, Delaney, if you could just give me a quick confirmation, that would be appreciated.
Yep, just need to click the slideshow part. Yep.
All right, perfect. Very good. So quickly, I think everybody on the line today is familiar with SAE, so I won't belabor that point. But what this slide is meant to illustrate is that for a long part of SAE's history, we have been a vehicle-centric organization, whether that vehicle is a car, whether it's an airplane, whether it's a big commercial ship. So a lot of our standards, a lot of our technical research has been, not surprisingly, focused on the vehicle. It's abundantly clear, and today's discussion is a great example, that the broader infrastructure is becoming an integral part of our work and our responsibility to the industry. So as we look at the next 10 years, 20 years from SAE, we are really moving the organization and adapting and growing like the industry is to provide the products and programs that meet these needs. So it's not just EV charging infrastructure, it's life cycle analysis, it's the utilization of data in standards and modern engineering, the way that engineers have used technical standards, over the past 25 years is changing. Specifically the way that the information and the data is being consumed. The use of standards is of course the same, but we are looking at a lot of new solutions and potential products that serve the industry's data needs. And of course, recycling and these other things. So the other big thing that I'll talk a little bit about as we move through the presentation is new work that we've done in the area of certification. So to loop back to what Jacob was saying earlier, I'm including this visual for a reason. About a year ago, SAE, through our sustainability practice, published a 50-page document. We called it the Charging Station Performance and Reporting Report. And what it was is very salient to the discussion about ChargeX, because it was the beginning of a framework for a structured format for diagnostic data or error codes to be exchanged between EVSE manufacturer and OEM. They're like OBD that SAE worked on in the late 80s and early 90s. There needs to be a common protocol and a language for communication. So we utilize this document as an opportunity to start that discussion. And what's really interesting is, as ChargeX has produced its KPIs and its other outputs, including error codes, this document has been an important part of that. So that's available for anybody who would like to see it. There's a lot of relevant, good information in there. So I'm going to skip along here. So as it relates to the products and programs that I mentioned, SAE operates a professional development training group. So in our training portfolio, we train about 12 to 15,000 engineers a year all over the world. We operate over 200 courses, and they're virtual, online, live online, on demand, in person. It's a nice variety of options. But what's interesting and exciting is I'm gonna switch around a little bit here. We just released this course. It is on the market. It is available. We are very excited about it. And it's called EV Charging Standards, Regulations, and Safety Principles. And the idea behind this course is to provide engineers and technicians alike with a fundamental understanding of the critical standards and communication protocols that govern EV charging. So at the time this course was completed, all of the information on J3400 was not 100% finished. So J3400 and NACS, that content is included in this course. So just because you don't see it on that second line there, it is embedded in this course, so that information is there. And as we march forward, this course will be updated. But broadly speaking, it's meant to give engineers who are transitioning within whether it's an OEM or an EV charging company or CSP, an idea of the standards and protocols, and most importantly, how do they actually use that information in their job? Especially if you have a younger engineer moving from one area to another, trying to understand ISO 15118 is not an easy process. And then when you tack on, 5, 6, 10 other standards or protocols, becomes quite a challenge to understand how they all work. So this course is meant to give the practitioner the fundamental understanding of all these documents while weaving in their impact of regulations and safety. So we launched it with our partner DECRA, a global organization headquartered in Germany. So this is available. Happy to answer any questions, but we're very excited about it. So the other big thing that is material to this discussion is SAE over the last year has been working on a new certification program. What some of you may not know is that within the SAE group of companies, there is an organization called Probitas, which sits in what we call the SAE Industry Technologies Consortium. And it's a part of our organization that brings together companies under legal protection to create, effectively consortia that produce best practices, ultimately leading to standards in a lot of instances. So with that as context, we pulled together some of the leading companies in the industry that you see on the screen. And we said we started this project by saying, what's the biggest problem? And it became very clear that one of the big problems in the industry was having a mechanism for certifying that technicians who are working on charging stations have the right skills and the right education and the right knowledge to do the job. So I'm sure everybody on this call is familiar with the EVITP program. SAE is as well. This program is not for electricians. This program is for diagnosticians, for the people that are doing maintenance and operations work. And the idea is that when charging stations don't, or you have a failed charging session, it is not always and arguably not often the result of an electrical issue. There's software, there's standards, there's protocols, there's troubleshooting. So what we did is we pulled together these organizations and we created a body of knowledge. What do the people that are fixing charging stations have to know? And we created 7 domains of knowledge, which you'll see on the screen here on the right-hand side, codes and standards and regs. You have the commissioning process, preventative, corrective maintenance, electrical, energy fundamentals, etc. And then it's probably a 15-page document that outlines all of the things that the practitioner needs to know and the skills that they need to have. SAE took that information and we turned it into an examination. So as of the past couple of weeks, that examination is complete. It is written. It's now in the process. We're working with an operational partner to deploy this exam. So people, whether it's technicians or people that are trying to come into the industry from a different industry, they can walk into a Pearson VUE testing center across the country, which they are in every major metropolitan city, and take the SAE examination, which was created by our affiliate Probitas. And when they pass that examination, they will receive an SAE International certification that they are, an approved certified EVSE technician. So it's a really exciting new program. We think that there's going to be tremendous need for it, which is why we spent a lot of time and resources building the program. So, of course, all of this relates to reliability of EV charging. If the consumer's not happy and they're not getting a charge for a variety of reasons, we need to make sure those charging stations are working. So from a commercial perspective, those are some of the things that SAE has been working on related to J3400. Thanks, Delaney.
Great, thanks, Mike. Now we'll hand it over to Josh Rodriguez from AASHTO, who will facilitate our Q&A and discussion.
Good afternoon, everybody, and thanks for joining us. So we've had some continuous questions pop up in the Q&A here, and Rodney has been on the spot answering them. So they are very, very informative. But I'd also like to open it up to anyone that wants to raise their hand, turn on their mic, come on camera, and ask some general questions to the panel. I'm sure some lively discussion would be welcome. And while we wait, I have a question for the panel. Is the J3400 standard for the connector what makes Tesla's network so reliable, or is it a combination of that technology amongst other things? Well, I guess that leads to the question, will the connector improve reliability across, the greater network?
There are some mechanical aspects to the CCS Type 1 connector that make it more prone to needing maintenance. The Type 1 or J1772 connector has this latch on the top of it. It's mechanical. And when it gets dropped, it can get broken. And when the latch is broken, you can't charge. The Tesla connector doesn't have as many bits that can break off of it. So there are some physical things that will lead to that. This one is an underappreciated thing, but I don't know if Teslas in general put the plug on the back of the car, and the stations have relatively short cables. That sounds like you might say, oh, well, they're just being cheap having short cables. But actually, having short cables makes them less likely to get dropped on the ground, less likely to fall into the mud. And because the Tesla system was designed around a single set of companies, all the cars had the connectors on the back so they could keep them to a certain length. So there were mechanical reasons they're more reliable, although with communication standards, because the first party charging station manufacturer and the OEM were the same ones, they could easily avoid the complications of communication and operability because they were writing both sides. So they could just seamlessly connect and start charging. The issue we have with the current CCS system is there are different companies building charging station networks and then vehicles. And you have essentially, we do not have currently, although we're trying to build that, as I mentioned, like a roaming system. You guys can, if any of you are older, you'll remember there was a time where you couldn't roam on your cell phone. And then there was a time where you could roam. And the government was involved with sort of making that happen. And now you can just take your phone overseas and just start using it. But that was not the case when that technology started. There's a very similar analogies for how the different networks are able to securely identify themselves, and then the cars are able to then roam onto those networks. It also has to do with bilateral arrangements between an OEM and a charging network, for example. But on the technical side, we're trying to facilitate that in the recommended practice in a way that is not done even in the international standards, because I guess the practically speaking is that like the other OEMs are coming into the Tesla system and the expectation is that it work as seamlessly. So everyone's trying to make that happen because that's the sort of expectation people have with the NACS system from a communications point of view.
Yeah, and one more thing, Josh, just from a serviceability point of view, and Tesla obviously was Tesla's own network, right, for charging network. And they managed to maintain that network extremely well. And again, the ease of use, because it was just a Tesla that was pulling up to getting charged on those vehicles, unless you bought an adapter, which many people did. At the end of the day, Tesla had a very single-minded focus as it relates to just charging Teslas. It's become much more complex now, and much more involved. And hence that's why the development of the standard is much more challenging than people anticipated.
Thank you. We got a couple questions. So one question in the Q&A, it sounds like there are physical features of the specific Tesla charging stations that made it more reliable. Now, with an open standard of J34, that still allows EVSPs to build stations at their own discretion. So maybe longer cables.
Mm-hmm.
So as you mentioned, the shorter cable avoided more frequent dropping. Now, if you have a longer cable or your station's designed differently than Tesla currently designs their stations, does that change the benefit of the J34 standard?
Yeah, I don't think that's like a primary thing. I just sort of mentioned it as like 1, 2, 3, 4, 5, 6, 7. But that's kind of why we mentioned that we increased the requirements on drop standards. Like 8, the standard, 8 is a really low number. Everyone could imagine it getting dropped 8 times a week. So like having a testing standard that only makes a connector having to be dropped 8 times was low, and that's what the old standards say, but our standards say it should be higher. They give it's a much higher number. And so that's an example where we've tried to cover that by increasing the requirements on sort of durability. And with regards to length, I think Tesla's latest stations have longer cables. I think that third-party stations will have longer cables. I think the other thing that will happen is some OEMs will provide flexible adapters, which sort of extend by a few feet the length of the cable, and that may mitigate the problem for some users that maybe have the charge port on the quarter panel of the car rather than on the back.
Super. Thanks, Rodney. Another question, I'm going to phrase this a little differently because I always like this example. Is this new standard, is this a VHS versus Betamax all over again? Are we seeing this is going to be the single adopted standard and we won't see the manufacturing of EVSP equipment with the previous standards?
It's even possibly a little more different than Betamax versus VHS, because with Beta and VHS, you had one group of manufacturers that included several people in another group, right? And they were nominally led by Sony and JVC and all that, but there were multiple manufacturers for both systems. The sort of strange thing with NACS is at the time that the OEM started switching to NACS, it was both a proprietary system and a majority market share system, which is sort of weird, right? Because the industry was thinking that, okay, well, all the other manufacturers are in the J1772 system, even though that's only 30-some% of the market now, okay, it's going to win eventually. That didn't happen. They switched. So what the people keep forgetting is, people talk about, J1772 and CHAdeMO cars, and all of that's really important for existing drivers that have cars. But the reality is Tesla is the majority market share one today, and all the manufacturers are switching into it, which means very quickly, especially as there's adoption of more EVs, you're looking at a huge percentage of the market being NACS. So I think it does represent for definitely for passenger cars, the system that for North America, and that's been clear through the adoption across the very quick adoption by the OEMs.
Thank you.
And Josh, just to add on that, if I may, this is Jacob.
Of course.
So, when you think about all the OEMs, saying that they will be migrating starting 25, you can almost picture vehicles that are being produced in 25, 26, 27 simply not being equipped with CCS anymore. So you'll peak at a point in time in the future where, you know, the CCS vehicles will simply not be increasing. Instead, you have the NACS vehicles increasing in quantity, or the park, if you will. And then as vehicles become aged and go out of commission, you'll see a decline of that CCS population. So, you know, over time, it just looks like that's where it's headed, given what trajectory the OEMs have declared already.
I think the important thing to realize is a lot of everyone's thinking about, what do I install now? Well, what you install today, like those projects probably started 3 years ago, right? When you're getting the money and getting the site planning and the engineering and the site approval and the permits and all that. So when you're thinking about, you know, when we're thinking about requirements, think about like, when are these stations that you're authorizing going to go in, and and are you trying to build these stations for new EV drivers versus are these sort of in-route stations where you want to capture a lot of drivers? I mentioned in my slides that we made some changes to make AC charging kind of cheaper and more cost effective. Well, the reason why that's really important, and this was a question that I sort of answered, but I think it's there's some things more to say about it. It was the question of someone asked whether the standard includes the AC level 2 terminology, and I answered that it was unanimously not included in the new standards. And but specifically, if you think about AC charging stations and you say requirements, and you're trying to today build a charging station that every car can charge at, you are going to have a charging station that has multiple outputs, or depend on your drivers having adapters. A charging station with multiple outputs and adapters, especially for the AC market, is going to be a lot more expensive. Remember that we want as many cars plugged into that kind of AC infrastructure because we want them to be there for a long time. We want them to have a place to charge when they park. So it's really important that AC charging infrastructure be as low cost, because if you look at countries like the Netherlands and things like that, that's how you get the high penetration of public charging, is to have the infrastructure to be cheap. If the charging station costs $8,000 versus $3,000, that means you can install less charging stations for the same dollar. So if you just singularly focus on supporting legacy vehicles, which I know is very painful for early adopters and everything, the truth is who you're really hurting is the people who don't have EVs yet, because we don't have an unlimited amount of money to spend on charging infrastructure. And if you can install 2 or 3 times as many stations for the same dollar by having simpler infrastructure, that of course has to be the new choice. That of course has to be the long-term choice if your goal is mass electrification. So, you know, what you might do for DC might be different, because that's an in-route charging. People really need to get that charge. But think about AC charging as where people park their car at night or park their car at work. So they kind of know the station, they know where they park typically. And those are key to electrification, those chargers. People talk about in-route, that's the hot thing, but the truth is that, you know, working class Americans don't take trips to upstate New York along the interstate where they need to charge. They work, they don't even have much vacation days. They need to get their car home at their apartment, have a place to charge, and they need to be able to maybe charge at work to sort of top off. And that's who we're not serving right now with the regulations, is people who don't have a garage, who need to charge their cars.
And that's a good transition into another question that came into the Q&A here. Considering equity, you know, how should CCS be maintained considering the used car market as you know, more new cars become NACS and the used cars stay on the road as CCS? And then given your comment about in-route charging, you know, and the fact that NEVI is designed for that network, how might you know, comment on if we're flooding the market with equipment with J3400, you know, how do we keep used cars on the road and ensure that CCS is maintained?
Yeah, so I think about thinking about getting all Americans into driving an EV through the used car lens is probably a bit twisted. I mean, eventually there's just going to not be that many used CCS cars on the market to electrify the other 99% of cars that are not electric today, which is really the goal that you need to have for, you know, climate change and electrifying transportation. But I will say that the more practical thing is just having transition times. So there will be a period of time over the next couple of years, maybe that indeterminate amount of time, where we require dual infrastructure. But long term, you really have to follow what's going to serve new EV drivers, because the fact is that, you know, a very small percentage of cars are electric today. So that really should be the focus for broad generational reaching public policy on electrification. But practically in the short term, you can have policies that allow early adopters to not be shut out of infrastructure, right? So I think it's really that people need to have a long-term and a short-term vision on how this transition is going to work.
Super. Well, if there's any other folks that want to raise a question, raise their hand.
I do see sort of one question.
Let's see.
Came in. Yeah, so we've really tried to in the standards, and I wrote a guest post on the SAE blog kind of about the improvements to AC charging. We've just going back 10 years ago when J1772 with the modern connector, actually it's 2009, so a bit closer to 15. But when we adopted that standard, most OEMs were not involved with electrification. They didn't have energy units as part of their, you know, company. And so when you compared some of the decisions Tesla made versus other OEMs, part of that is because they were always providing both sides. And when you provide both sides, you optimize for the whole system. Unfortunately, it was the case that when OEMs were not involved with the infrastructure side, they are now, of course, but when they weren't, you know, OEMs could make decisions that lowered the cost of making the vehicle, but maybe made the infrastructure more expensive. That's not the case now. And so that's at the root of some of the changes we made to more align things to the way Tesla did things, because it was a little more eyed towards the system optimization cost, which of course is the cost that society bears. So with the multi-unit and apartment changes we made, those changes should allow you to install more charging infrastructure at a lower cost and make it more efficient. And that's why they're sort of really important changes, even though some of these changes mean that some of the legacy vehicles may have interoperability issues. When we're talking about charging where people at home, these stations are generally used by the same group of people, and those are going to be new EV drivers. So when you look at AC infrastructure that's not en route, that's destination charging, especially for serving home users, you really have a lot more, it's the same group of cohorts using the station. So you don't necessarily need to think about the problem in terms of charging every car. You think about charging the cars that people park at that location.
Just to add some context to some of the questions that are coming in. So NEVI funding is not the only federal funding provided for EV charging. NEVI funding is a formula program covered under Title 23 for state DOTs. It's very specific, and there are very specific standards for that spending. There are a number of other programs, not just out of federal highways, but out of EPA, out of HUD, that provide for funding that don't have the same requirements as the NEVI funding does. So there's a clear difference between the NEVI network that they will be building out for along the alternative fueling corridors versus what you might think as community charging, opportunities for multifamily housing and such. So there's very different standards and requirements under, you know, the different source of that funding.
Yeah, that's a great, and I know that one of the things we proposed is, you know, sort of connect stations that don't have cables attached to them, which is what they do in the rest of the world for AC charging generally. And there are programs funding that work even prior to us endorsing it in the NACS standard for street charging in New York and Boston, for example. So that money is not NEVI money, that it doesn't meet the requirements. Another question got put in, does that mean level 2 infrastructure is obsolete? No. The NACS vehicles, they can charge off level 2 stations. But when you say J1772 level 2 AC chargers, that implies a very specific kind of station with a very specific set of requirements. Those requirements are not, when you say AC, J1772 AC level 2, that means you are on a more restricted set of voltages, which means that you maybe have to install additional transformers and equipment, which could double the cost of the station. You have to have a fixed cable attached to the station, which means whoever puts in this infrastructure is in charge of maintaining the cable. So if it gets damaged, that cost has to be, that cable has to be replaced by an electrician, which means you got to roll a truck, right? And so that's why street charging or parking garage infrastructure in other countries, it would not meet the requirements of J1772 level 2, but is lower cost. So really, it's that J3400 has configurations which are not, of course, because J1772 level 2 means you have a J1772 connector on it, right? So if you have a mandate for AC level 2 J1772, that may mean that yes, you'll be able to charge those legacy vehicles in addition to the new vehicles with an adapter, but that also means that you may have a higher cost installation. And so when we talk about new stations, especially ones that are installed where people park, removing that requirement and going more towards a what's defined in 3400 allows the possibility of installing cheaper infrastructure. So that's where you might have a different strategy on in-route charging, where you have more of a try to charge every car as much as possible, versus more cost-optimized charging that's focused on getting new EV drivers to charge at home, even if the home is an apartment or a street along Philadelphia, right?
And Rodney, along those lines, perhaps, you know, for legacy vehicles, some of the OEMs might offer a retrofit to the onboard charger that allows it to be charged with the 3400 voltage range. Yeah, that's possible.
That's possible. And some OEMs are finding that their vehicles are already compatible and they'll be issuing software updates. So
yeah,
and some OEMs will be providing adapters because they've verified their cars are interoperable with 3400, like in this model year, right? So a lot of OEMs are providing adapters. So I think the thing to sort of think about, and this may be sort of bizarre for, you know, people writing regulations, but if you say you require J1772 AC level 2 in your requirements, that as of, you know, the publication of our standards, that means your sort of your primary way of connecting is for a minority market share a connector system. So that's kind of something for people to think about. You know, yes, today those 2/3 are Tesla cars, but very soon they will include the entire North American passenger car manufactured cars. And so you have to think about, should I be mandating the legacy requirements, if it's for serving a minority of the market share today, when you're looking at future looking infrastructure requirements. So I know that's a change for people, but I'm trying to be a little brutally honest that J1772 is going away, and that you need to start thinking about how you're going to make that transition work. How are you going to provide the transition path for early adopters and people like that? But essentially, it is going away. So you got to start thinking about what your requirements are going to look like.
All right, we have a couple more questions in here before we wrap.
Yeah, I see.
the-
So some Tesla supercharger. So there are, I mean, I don't know how many there are now, maybe 40 of them in the country. There are superchargers that have like integrated adapters. So when you get on your app, you sort of tap a button and the adapter comes out instead of just the plug. Tesla generally calls that Magic Dock. There's something similar for AC charging. Those, I think stations like that could meet NEVI requirements because they can provide both types of outputs without the customer having to have an adapter. I don't think that's going to be the norm. I mean, it is a pretty complicated system, but at the same time, it seems very slick and simple. We'll have to see how common these sort of station integrated adapters are. And I'm looking at the other questions about, well, this is more of that question, the one about the community CFI is more of a Jacob question.
Yeah.
So just as a comment on, again, level 2 at NEVI stations, you can install level 2 at NEVI stations, but the floor must be met for the NEVI standard before level 2 can be installed. So again, these are very specific programs along alternative fuel corridors for state DOT contracts. And it's less of a technical and hardware limitation and more of a formula funding requirement by federal highways.
Yeah, so at a basic level, SAE J3400 is the standardization of the NACS system, and it provides AC and DC charging at various power levels. But just to reiterate, and I think I answered this question in the text, the level terminology has long been sort of problematic. You could have a level something station and one of them could be 2 or 3 times faster charge than the other one. The OEMs and even the charging station operators decided to move toward the kilowatt terminology, because that consumers see that on their front panel when their car is charging, and they see that number in their app, and they're getting more familiar with kilowatts, and they know that a higher number is better, and they see that number and they go, oh, this station charges at 200 or 300 kilowatts. That's good. So when you just say, level 2, I mean, people use the word level 3, it's not even a word, but let's just say level 3 station. Okay, is that 50 kilowatts, 100, 200, 400? It tells the consumer nothing. Even though the industry's more kind of the marketing people kind of loved it, but technically it was unanimously rejected to keep the level terminology for charging because it didn't really communicate much to consumers.
And Rodney, there looks like there's a question, and I'm assuming this is surrounding medium and heavy duty, because I don't know why you would
Yeah.
want to charge a light duty at a megawatt, but
Okay, so that's a separate standard. The megawatt is a different J number, and that's being standardized in another forum. My colleague works on that along with other people. So it's not the same plug. But there is the yeah, and that infrastructure is really meant for heavy duty vehicles, which are almost in continuous operation. Think like a city bus, not even necessarily a school bus. A school buses only drive a couple hours a day. More like a city bus that drives like 23 hours. Those vehicles need to charge at 1 megawatt plus. So 3400 is not the same as the megawatt system, no.
So I think the question or the confusion might come with the fact that, you know, the megawatt MCS system is designed for, you know, anywhere from 1 megawatt to 4.5 megawatts in the most extreme case of power delivery. And if you look at, you know, where J3400 thresholds are, theoretically, you can say that it's also charging at megawatt rate, right? So then, you know, where does the medium duty, and that's not to say that you cannot do it, but that's what the spec says, right? But that doesn't, can you actually build it to actually work and last? That's to be determined. But the medium duty side, though, they have adopted CCS, right? So medium duty truck that various truck manufacturers that are coming out with have sometimes one CCS or dual CCS connection to charge their battery system. Now, will they migrate to an MCS in the future? That's what they'd like to do, I think. But in the meantime, will they continue with CCS or will they do J3400 if that's what, you know, meets their requirement? I think these are all things have to be seen. It's hard to predict at this moment, but the trucking industry, I think, as Rodney pointed out, I mean, their needs are much more power delivery at much faster time, and so MCS is the long way there. But for some of the other smaller vehicles, you know, will something like a CCS or maybe a J3400, you know, suffice for you know, a short haul or a, you know, short delivery type vehicle that has a you know, mid-sized battery that that takes care of a daily route as opposed to a long haul over the road where it needs to be charging along the way.
thanks, Jacob. And
I'm sort of running out of time, but I do see there are some more questions.
Yeah, I'd like to take
I'll
this
let you
last
say,
one
Josh.
because
Okay.
I would say let's take this last one, on the capacity, because I think there's a lot of misunderstanding and misinformation, and I think this is a good question for it.
Okay, yeah. So the NACS system today, like the Tesla, I mean, other than the Cybertruck, they're based on like 400, 500 volt battery packs. When you double the voltage, you immediately double the kilowatts, and so Tesla is deploying for the both the third-party manufacturers building 3400 stations, and Tesla themselves are moving from 500 to 1000. And doing that automatically doubles your charging rates. And so NACS, if you're doing cooling from the station side, can do about 900 amps maximum. So in that case, in theory, NACS almost gets to 1 megawatt with the system. So, but of course, for a lower voltage battery pack, it's going to be half that. So only 1000 volt vehicles can kind of get above that 500, 400, you know, kilowatt zone. And that's a transition that's ongoing currently. But the nice thing is when you have 1000 volt station, you can still charge the other cars. But so yeah, I think that's the answer for light duty. They can go quite high. And that's mostly the increase in the number is switching to 1,000 volts. So that 350 becomes, 700, just like that.
Christian, you have anything to add before we wrap?
No, I think Rodney, you understand why Rodney is our chair of our committee, and he obviously dives into the depths of this stuff. But the effort is there. The good news is all of our colleagues and all of the subject matter experts that are supporting this and helping this to get it accelerated and get this done. It needs to be done in order for us to develop and build these vehicles that we have to deliver in the future. So thank you very much, Josh and Delaney and the entire team. Really appreciate it. And Jacob, for all your efforts and your time today.
No, thank you, Christian and Michael and Jacob and Rodney for all the great information. We really appreciate you sharing that today for the webinar. And thanks everyone for joining. And those here on the East Coast staying a little bit later than 5 o'clock. That's always kind of the bane of being on the East Coast. We got to stay a little bit later to make sure that everyone gets to join from the West Coast and beyond. So Delaney, anything to add before we wrap?
Nope, but thank you, everyone. Thanks again to our speakers for presenting all this great information. And thanks again, everyone, for attending. We'll send out the recording and the presentations for you all to review at your leisure. And I hope everyone has a great rest of your day.
Thank you, everybody.
Bye-bye.
Bye-bye.